factor now. So similar to area scale factor, except we're talking about 3 dimensions this time. So what about when we're asked to find volumes of similar shapes instead? That is, measurements which are measured in 3-dimensional space. So like area is mentioned in 2-dimensional space, length is in 1-dimensional space, volume is in 3-dimensional space. So if a 3D object is enlarged with a scale factor k to produce a similar object, then we can use this equation. Similar to the last one, but we're talking about volume. So notice that k is cubed. So the new volume equals k cubed times the old volume. So k is cubed when we are dealing with 3D space. Similarly, when we're talking about 2-dimensional space, k was squared. And when we're talking about 1-dimensional space, k was just raised to the power of 1. Okay, so let's apply this to an example, very similar to sort of how we did the area ones. But in this case, the equation we're dealing with, k is cubed. So if we're asked to calculate k cubed, it's going to be the new volume divided by the old volume. And then to get k, you would cube root that answer instead of square rooting the answer. So let's see how we apply that in a real world. So we've got a little example. So we've got cylinders A and B are similar with heights 2 centimeters and 4 centimeters respectively. So they've given us not the volume at this point, but in that bit of information they gave us just a 1-dimensional length. Cylinder A has volume 10 centimeters squared. So cylinder A is the original, and its volume is 10 cm cubed. I said squared, sorry. 10 cm cubed. So that's the original one, and this one is the new one. That one in purple. Find the volume of cylinder B. So that's what they want us to work out. What's the volume? So we have a a pair of corresponding 1-dimensional lengths. So we can find the scale factor. So we're going to find the scale factor first. So it's not the fact that we've been given both volumes and then we go back and solve for the scale factor. We've been given 2 1-dimensional lengths, so we're going to find the scale factor first, and then we're going to find the new volume. So find the scale factor first. What is it going on about? Lovely. So our scale factor, remember just what the basic scale factor. Scale factor equals, it's going to be the new length. In this case we're talking about height, because that's the information we've been given. New height over the original height. Groovy. So new height over the original height. You can see from the question above, the new height is 4 and the original height is 2. So let's go plugging that in. K equals 4 on the new one divided by the original. So what's our scale factor? Our scale factor is 2. Wicked. And now we can find the new volume. Let's find the new volume. So find the new volume now. So we can use the unrearranged version of the equation above. New volume equals k cubed times the old volume. So let's write that out. My color coding I'm so fond of. New volume equals k cubed multiplied by the old volume. Old volume is just the same as original volume. So I'm going to say original volume multiplied by the original volume. So the common error would be people would forget to cube the k. That when we're talking about that, we need to, like volumes, we need to cube the k. So our k is 2, because we calculated that, so let's sub it in. 2 cubed times the original volume, which you can see is 10. 2 cubed times 10, what's the answer going to be? Equals 8 times 10. So it equals 80. Don't forget your units. What are the units going to be? They're going to be centimeters cubed, because we're talking about a volume here. Please don't forget your units in these problems. So that was a pretty easy one. Slightly different emphasis to the area problems, because in the area problems we kind of gave you 2 areas and you had to solve for k. Okay, here's another example, and a little bit more complicated one, slightly. So for each pair of similar solids, try to think what kind of solids do you have in question A. That's right, they're square-based pyramids. Question B, you sort of have like a cone that's had a cone cut off. So initially imagine there would have been another cone up here. So it's like a cone, a large cone, with a small cone cut off from it. So for each pair of similar solids, find the unknown length. So we're basically asked to find x. So what information have we been given? So we've got, let's call this one the original, and let's call this one the new. Important information that we've been given in both of them is we've been given the volumes. We've been given the volume of the original and the volume of the new. So we're going to probably have to find k first, and we're going to use our volume formula to find k, and then we're going to use k to find the new missing length. So let's find k first. Let's write a little instruction to ourselves so we remember what we were doing. Find the scale factor first. That's what we're planning on doing. So in this case, remember when we're talking about volumes, it's k cubed. So scale factor cubed equals the new volume, and it's always new over the old. So new volume over the original volume, or old volume, whichever word you prefer to use. So let's substitute in what we know. We know k cubed, well we don't know yet, but we will work it out. The new volume, as you can see above, is 64 centimeters cubed, and the original volume, what was it again, is 27. Interestingly enough, they both happen to be cube numbers, so maybe we're going to get a nice answer. We're going to get an awkward looking word. So therefore k must be the cube root of 64 over 27. Thinking back to our thirds, we can break up the cube root. Cube root of 64, because they're both cube numbers, so that's a good idea. Cube root of 27. So k, cube root of 64, what's it equal to? It's equal to 4. Cube root of 27, what's it equal to? It's equal to 3. So we've got a nice scale factor there of 4 over 3. Oops, I'm going to actually just keep going down the page. This one blocks it off from the next question. So I'm going to do the next part down below here, because part B I'm going to be doing over on the right. The question above actually asks us to find the unknown length. So our two corresponding lengths we've got, notice they have to be corresponding, so we have 6 and we have x. So we're going to use the fact, try to think, does x have to be longer than 6 or shorter than 6? According to our scale factor, it's going to have to be longer. So what we need to do is we need to do, say that x equals our scale factor. Yeah, that's right, x equals our scale factor, k, multiplied by the original length. Makes sense. Or you could have set up a ratio. You could have gone 4/3. Hang on, what am I saying? Yep. So you could have also done this. So I'm also fond of, you might recall me doing this, so I'll actually show you this as well. X equals the new length over the old length. K equals the new length over the old length. So the above one I did was just using the basic formula from 2 lessons ago, but this version is kind of the way I tend to sort of do it. New length over the original length, which is just a rearranged version of the formula that's in the problem box. So it's the same thing, but I'll just try to be consistent with the way I work it out. We know what our scale factor is. We know it's 4 over 3. Let's plug it in. 4/3 equals, and our new length is x. So leave it as x. Our original length, what was it? It was 6. And I'm fond of the old cross multiply, so that's why I'm kind of doing it this way. Just in case any of you do choose this method and you're not sure what to do next. I'll show you cross multiply. Whereas the above method here, it's very easy. You already just plug it in. So cross multiply, that's what we're going on here. What we have therefore is 4 times 6 is 24. 3 times x is 3x. So x must equal 24 over 3. So x equals 8. Look up the diagram. What are our units? It's right there, centimeters. Now critically look at your answer. Decide, does it make sense? X is 8. It should be bigger than 6. because 64 centimeters cubed is a bigger volume than 27 centimeters cubed. So it does make sense going from 6 to 8, it got bigger. So now we'll finish that particular question. Let's just finish off B. Same thing, find an unknown length. Now we've got two shapes, as we always have. I'll call this one the original. I'll call this one the new one. There's my little colour coding method. We've been given the volumes of both. So we've been given the volume of the original, and we've been given the volume of the new. So we're going to need to find K first, of course. So find K first, using the fact that K cubed equals the new volume over the original volume. Over the original volume. So we can go K cubed equals our new volume, what's that? That's 50. Our original volume, it's 10. 50 over 10 just simplifies, makes life a bit easier. So don't forget that's K cubed though, not K. So K cubed equals 5. 50 over 10 is just 5. So K must be equal to the cube root of 5. You might be tempted to work this out as a decimal, but I would suggest just leave it as a cube root of 5 for now. So then you're not going to get around an error so much, and you're not having to write out a decimal to lots and lots of decimal places. So put that down. What we need to do now is find the missing length. So our corresponding lengths, we've got x and we've got 9. So I'm going to use my little method, x and 9. So remember, just a regular scale factor k equals the new length over the original length. Okay, original length. And looking at our diagram above, actually we know what the k is. It's a cube root of 5 equals the new length according to the diagram above. Have a look, it's 9, and the original length according to the diagram above is x. It's an interesting way you can cross multiply it. If you want, you can think of that as root 5 over 1, and then you can cross multiply, if that makes sense. Or you can just think x times cube root of 5 equals 9, that kind of thing. So if you cross multiply, how could you kind of set it up? So you could kind of go, if it kind of makes your life a bit easier, you can go x multiplied by cube root of 5. If that makes it a bit easier for you to set it up, feel free to do it that way. Okay, move that out of the way. Equals 9 times 1, so it's just equal to 9. So therefore x must be equal to 9 divided by the cube root of 5. Cube root of 5, just going back to solving, and we'll talk through our algebra is good here. So you didn't have to cross multiply, as I said, you didn't have to write it as cube root of 5 over 1, but if it helps you do it, cube root of 5 times x equals 9 times 1. And then we have to bung this into a calculator, so you would, on your TI Nspire, you would have to put this into a calculator, because it's not one that you can easily work out without calc. And if you do that, you should write it out to lots of decimal places first. So to lots of decimal places, it would be 5.26323 ... and then round to 3 sig figs. X equals 5.26. Have a look at the diagram above. What are our units? It's centimeters, because it's just a length. Does it make sense? Let's see, on the new diagram it was 9, on the original diagram it was x. It should be getting smaller because the volume went from 50 to 10, so going from 9 to x, it should become a smaller number. So you can sort of use that just to sort of critically analyze, does your answer make sense at all? And thank you.